All right, there we go. Hi everyone, how's it going? Team here, and this is BXJS livestream, and we are continuing our gaming review processing thingy. I honestly don't think it should be called gaming knowledge graph because we're not really building knowledge graph so far. I mean, we might dive into that category, but so essentially, what we're going to be doing today is we're going to be using text embeddings to try and see if we can get relevant games by using reviews, right? So this is what we discussed essentially initially, and we can finally get to that phase after collecting the reviews. I also will talk about that briefly. Hi Kenneth, welcome to the stream. So there's two things that happened basically while I was fetching the reviews over the past week, I think, right? Thing number one is that I discovered that Steam API doesn't actually work. Like, just straight up doesn't work. I've tried to fix it. I've tried to debug what is going on, but the problem is that like you're asking it to give you hundreds items per page, I tried adding all the properties that is possible, removing them, just giving the bare minimum. But what ends up happening is that, first of all, it not always returns 100 entries, even if there are 100 entries. And second of all, I still don't know why, but at some points it just stops returning further results. As in, like, if we take this game here, right, it has like 400 reviews. And if I run this, let me just quickly run it. Yes, if I run this, right, you will see. Oh, did they fix it? No, they didn't. Yeah, there you go. So you can see what's happening basically, right? Sometimes it will fetch less reviews that are available, and I know this for a fact because it said there is 679 reviews. Then it fetched 200, so this looks correct, right? And then the next page is for some reason 65. I have no idea, right? And then the next page is 0 new reviews, and then it just starts repeating the same cursor over and over again for 2 pages and never ends. This is basically what's happening. I don't know why this is a thing. I don't know how to fix that. I have no idea why it works this way. It seems like a bug, but like I wouldn't even know where to approach it. Hi Marina, welcome to the stream. So essentially what I decided to do is I decided to just, having some experience working with Steam's API and knowing how broken it can be, I just decided to skip it completely and just go for open critic reviews. So this code works fine. API returns stuff. I did enhance it a bit. So essentially I've added a bit that caches the open critic API responses in case there are some problems with fetching the actual reviews, so that you don't hit the API rate limits. That, like, it's pretty strict. I had to run it over like 4 or 5 days or something to fetch those 20 games. And then, yeah, so I collected the data set. There is now 20 games that we outlined last time. They have all of the reviews from OpenCritic with full text and everything. If you're curious, the data set is uploaded to release tag on the GitHub. It is like 100 megabytes, pretty big, but yeah, there's like a lot of stuff in there. So yeah, this is what happened over the past week, I guess, right? And the idea now would be to, first of all, filter out the reviews, because as far as I understand, the reviews are not exclusively in English. So like some of them I remember seeing was like Chinese and some Arabic languages and, whatever. So there's like not purely English, but I believe the OpenCritic actually gives the language. Yeah, there you go. So there's a language in the API. So we need to sort the data set a bit and remove the reviews that are not in English. And the next thing we're going to do is we're going to use embeddings to, well, I want to try two things, right? So one thing that is interesting to me that we discussed initially is, can we take gaming reviews and then use text similarity to essentially find games that are similar using the descriptions from reviewers? In my head, that makes perfect sense, right? It seems like it should work. And the second thing is that since we're using text embeddings, in theory, we should be able to actually search for games like semantic search, right? So I should be able to say, hey, I want to ride a horse and I want to shoot guns. Show me all the games where I can do that. And theoretically, it should give us this stuff because majority of reviewers typically mention stuff like this, right? The features and what's happening in there, what are the mechanics. So in theory, we should be able to do this sort of semantic search over the reviews or over games using reviews, right? So this is the two things I want to try today. We're gonna see how they go. I honestly don't know. So so semantic search is super straightforward. Like there are libraries literally that you can just take and use. Now the similarity stuff is a bit trickier. Like there are also libraries that can basically compare multiple texts. The problem is, in our case, we need to compare many to many, right? So we have many reviews for each game, and then we need to find the games that are similar, not the reviews. There are, from what I understand, I talked to basically experts who are working on NLP and things like this, and I was told there are basically two ways of tackling this. One way is to just throw the reviews together and just create one big document and create embeddings for that document, which, I think theoretically should work. We're going to try. I don't know how many or how big the document will end up. I don't know how many reviews we're going to have. The other way of doing it, which is basically generating the document embeddings for each review and then taking a mean average of all of those embeddings and seeing if, that gives us the result, basically. We're going to see what ends up working, what not. This is basically R&D stream at this point, right? Because I don't know if any of that will work. Well, okay, I'm lying. I know that semantic search for sure will work because that's a thing that is super easy to set up, super easy to use. But the whole similarity aspect, we're going to find out. Again, we're not going to be using anything fancy for similarity itself. We're just going to use basic cosine similarity, also super straightforward. And, there's bunch of ways of doing it, essentially. No need to invent anything. But before we dive into all of that, I wanted to talk a bit about text embeddings and what they are for those of you who never heard about it or aren't aware, maybe. So just a short explanation. I mean, if you Google it, there's plenty of articles. I just thought I would take the one from OpenAI because it does a pretty good job of outlining things. So essentially, the idea is that you take words, phrases, or documents and convert them to vectors, right? So you represent them as a feature vector that has X dimensions of features. And obviously, the more features you have, the more specific you're going to get, right? The idea is that in the end, the words that have similar meanings, they're going to be close to each other in those X dimensions, right? So this image is probably not the best representation of what I'm talking about. But yeah, this one is good, right? So like animals are going to be clustered together, athletes are going to be close together, films are going to be close together, and so on and so forth. This is extremely simplified representation of it because there's just 3 dimensions here. I think majority of the feature vectors of, if you take like bird or whatever, they have like thousands of dimensions. So yeah, this is obviously just for humans to sort of comprehend it. But yeah, essentially, yeah. Once you convert it all to vectors, you can do things like, hey, we can actually use cosine similarity, right? To just figure out if the vectors are close enough to be similar enough, right? And things like this. It's an absolutely fascinating thing. I am by no means expert in it, but I sort of have a brief understanding, let's put it this way, as an engineer, right, of how to use that. So this is what we're going to be using today, and there is a library called Sentence Transformers. What was it? Sentence Transformers? No, wait. Sentence Transformers. If I remember, I think it was Sentence Transformers. It was a Python library. Yes, there you go. Sentence Transformers. So this is the library that essentially provides all the tools on top of BERT for sentence and document embeddings. It can give you a way to do a semantic search. It can give you a way to do a semantic text similarity, and all of that essentially out of the box, also including pre-trained models, which I think should be fine for our case. Like, typically, when you're dealing with natural language in a specific domain, you want a model that is trained for that specific domain because it is quite likely that you're going to have some sort of a slang or, domain-specific terminology or something like that. While games do have this, it's usually not that much. Like, there are some terms, but I think it's neglectable, essentially. Okay, we're going to see, but at least in my head, it seems like it shouldn't be too much of a problem, right? So just using generic pre-trained BERTs that is just trained on like News Corp or whatever should be fine because, well, the reviews are typically written in sort of, how do I put it? Literature language, I guess, right? So it's not slang, it's nothing like overly domain specific. It's not Reddit comments. That for sure would require a proper like separate model that is trained on lingo that is used there. So reviews tend to be a bit more closer to actual like proper English, right? Let's put it this way. But anyway, let's dive into the code, I guess, right? So we got our data sets. And first thing we need to do is we need to actually filter it, right? So we need to take all of the files, we need to go through them, and then we need to only leave the English ones, right? So this is, let's call it collect English MJS, and I already have some code over here, so I was like testing out stuff, so we're just going to use that. Essentially what we do is we take the dir, we get all the files, we get all the JSON files. In this case, we don't really care about that. We load the files, right? And then in this case, let's console log. Yeah, okay, so this was the code I ran last time to check how many reviews I have. So pre-processing, filter, and we can, yeah. So as you can see here, there is 20 games, and well, some of them have like hundreds of reviews, others have dozens at most. So pretty varied data set. I mean, it's not overly large, so ideally you want to run experiments like this on something a bit larger, but I think for our case, that's probably enough. So we're gonna see. Okay, now we want to do what? We want to, I think it was language, right? So this is, let me, yeah, right. So it won't be, so every one of those reviews, so filtered reviews, right, is what we want to do. We want to say data filter, and then we get review, and then we filter by review. So if I open the file, I think it is literally just opencritic language. Yes, so it is .opencritic.language. We collapse that, and then it should be NUS. Is it always NUS, or is there like NGB or something? Okay. Right, so there's also the language detected by Mozilla. You know what we can do? We can probably just collect that, right? Let's do this. Let's just go like that and say, okay, get our console log. I'm just gonna keep the filtered reviews label. That's actually filtered languages, but that's fine, right? Okay, let's see. So NUS, yeah, so it seems like NUS is for English and they don't really use any other, which is great for us. So it doesn't seem like there's NGB or anything like that, which, I mean, some websites tends to have a very dirty data that is pretty hard to filter out properly, but it looks like we're good. So by filtering NUS, we should be fine, right? Which means we can say filter language equals NUS. And then we just say filtered reviews length. Okay, so now once we run this, we should see less reviews, and not significantly. So majority of reviews are in English, which is, you know, makes perfect sense, I guess. Majority of outlets in gaming scene are English language. So collecting these data sets for other languages would be a bit more tricky. But luckily for us, we can just go with English. All right, so we got that, and now I guess let me think about the structure. So essentially, if we look at the library for the sentence transformers, hi cat, what's going on? The way that you use it, so let's go with the text similarity, right? So you have to split things into sentences. So this is your document 1, document 2, essentially. Then you encode them into the embeddings, and then you can basically use cosine similarity or whatever to compare them, right? So what we want is a set of documents that are, essentially we just need a set of texts, right? That we can then split into sentences using something like an LTK, and then just generate embeddings out of that. So, okay, cool. Which means that we need, so what we need to be here, so we filter it, and then we're just gonna map, because we don't need the whole thing from the data set, right? The whole object, right? There's like a lot of things. Okay, so this is gonna be data opencritic game name. Yes, we're gonna get the game name just for the sake of it. Language is always gonna be English, which is fine. Okay, I think we're gonna keep URL and title just for the sake of it, right? Data URL. Gonna keep data title. And then there is, okay, we got the HTML, which is not interesting for us right now because I think Mozilla's algorithm did a good job of cleaning that up. But we should also have, there we go, there's a text, text content, right? So this is what we want. Text is going to be data, text content, right? Okay, to do that, and then we need to, output dir is going to be dataset English. So we're going to create a new folder. Probably should do that now. mkdir dataset English. And we should also do touch dataset English git kip. Okay, so we are gonna, okay, we did that. And then now we need to do, I'm wondering if we want the game tied to every review or if it's enough to just say, hey, there's this one game and then there's a set of reviews. You know what? Let's just keep it this way. We can arrange it in Python later. That's not a big deal. Okay, and then we do write file, right? No, that's a wrong one. We need one from promises. So await write file. Join output dir file. Yeah, we're gonna keep the same name because why not? And then it's gonna be JSON stringify filtered reviews, right? And I should probably specify that this is a UTF-8 so that we don't have to do the whole toString thing. Okay, so in theory, once I run it, we should have a clean data set of English files, right? So this should give us nice data set that only contains English reviews, and if we just scroll randomly through them, that looks English to me, right? So this seems fine. Probably also should clean the text a bit because I see a lot of line breaks and tabs and all that business, but yeah, I think we're good. Yeah, okay. I mean, it definitely needs minor cleaning, but overall seems fine. Okay, cool. So we got that. Let me ignore. Yes, I can do that, right? So we should be able to ignore. Yeah, that should be ignored. Cool. Let me commit that. Git add dataset n reprocessing. Git add git ignore. Yes, no. That is, I don't want to commit my Steam API changes because they don't work anyway. So why bother? Okay, add preprocessing script that extracts English reviews. Okay. I'm sorry, what now? Okay, there we go. You know what I'm gonna do? I'm gonna stash this into new stash so that it doesn't bother me anymore. There we go. Okay, so now we got our data set, which means that we can do can create similarity folder, and then we can create what do we call it? Call it generate embeddings py, right? So it's gonna be our Python script. And now we're just gonna copy this whole thing from here. And you know what? In the beginning, we're just gonna try and run it because I'm like 90% sure it's gonna fail. And there's also, we should probably pick a different model because this one is probably super tiny. Python, where did I put it? Similarity, okay. Yes, pip install sentence transformers. I have not used that library before, but from what I understand, this is like one of the easiest one to use if you want to do document embeddings, because everything else essentially requires you to do it manually, which is a bit of a pain in the ass, basically. All right. Yes, this model is like 19 megabytes, which means not going to be very good for our very long review. So we want something larger. Let me see. So while it's running, let's see what models do they have. Semantic search, re-ranking, pre-trained models. There we go. So this one is which one? All mini LM L6 V2. All mini LM. Where the hell? There you go. It is performance average. So it is, yeah, okay. It's very small, but basically semantic search, average performance, and embeddings score is suffering from because it is small, right? So which one is the best one essentially? So we want best performance for semantic search, essentially, and similarity, right? Multi-QA, okay. I mean, we don't really care about multilinguality. Is there like something that does not have multilinguality? Performance, sentence, embeddings. I mean, performance is also not that much of importance because we're only going to do embeddings once and then just compare them, right? Average performance. Well, okay. It seems like this basically all MPNet base v2 is what we want. It's Microsoft MPNet base model. That is, I guess, fine-tuned for their task, which is fine. So we can go with that. Okay. Yeah, okay. So example works. Let's run it again, because this will download the new model. And once it does, what we need to do is we need to read JSON and Python, and hell if I remember how to do that. So Python read folder. Yes, I'm gonna remember how to read things in Python now because I have to Google that every time. I mean, it's the same for node.js. I never remember how to do that. Okay, yes, for file and files, that's what we want essentially. And we also need an LTK here, so I'm just gonna comment all of this out. We're gonna start with, what am I pressing? That is a wrong button. Gonna go import s, so there's the model. Path is gonna be data set n, right? So there's the dir, okay. Your path is probably a terrible name for it, so let's call it dataset path. You know what? Let's just use camel case. I'm way more used to that than underscores or anything else. Okay, we got that. Print file. All right. Yes, it downloaded. It works. All right. So if we run that, it is gonna say this is all the stuff. So now what we need to do is we need to if file how was the Python string ends with. That's quality content right here. This is exactly what you wanted to see in a programming live stream, right? .json, there we go. And if ends with continue, there we go. Hey Wise, welcome to the stream. Is that how you do not in Python? Because, oh God. Or is it if not? Man, I'm searching for wrong things. Python, if not. Is it just if not? I keep forgetting, like in some cases you can do exclamation mark, I think, but in some cases it has to be like word. And jumping between JavaScript and Python can be a bit confusing. Okay, there we go. So we got file name. Right, so we got file path, which is gonna be dataset path plus / plus file. Yeah, that is wrong. Okay. And then we need, oh boy, okay, how do I read JSON? Python read JSON. There we go. Just read JSON from Python. Yes, import JSON, f open. Yes, there we go. That's exactly what we want. So we need JSON to import over here. And then we open our file. We open file path. Load our data and do print data. Let's print the, so theoretically that should print the first review, right? Yes, it does, and it seems to be working just fine. Okay, cool. Obviously the text is a bit too large for us, but that is perfectly okay. So now we need to use an LTK text to sentences. There was like a world tree tokenizer or something among those lines. Yes, so we need that, and then send tokenize. Yes, this is what we want. Import an LTK. I think I already have an LTK installed because that's one of the tools I'm using pretty much all the time. Okay, and if we do that, tokens. Okay, so for review in data, we do review, and then there is text content, I think, right? Text, no, it's just text. Okay, so it's just text. Then print tokens. So theoretically, we should see now a bunch of sentences. An LTK text. Okay, text is wrong. Now let us. So what are you? Is it like that? To this day, I'm still every time I use Python. No, okay. Dict has no attribute text. Wait a second. Oh, wait a second. What is it? Text. Key error text. So there is some reviews that don't have text, I guess. Is that the problem? If not review text, or I guess we can say if review. Yeah. Can I do that? So if there, no, I mean that would still throw an error, right? If it's not there. So we need to say if not review, I guess. Let's just check for broken reviews. Is that what it wants? Key error text. Okay, so there is no text there. Okay. If text in review, are you gonna, so review exists but text doesn't exist on it. How is it even possible? There we go. Okay, cool. So that works. And you know what, let's let's just break on the first one. Okay, cool. And then see, do we need any additional cleaning? Because it seems like it no, okay, we still need this cleaning, right? So it still has this /n and then like a ton of, yeah, that's I wonder if that's going to be a problem for tokenizer. Maybe once, but you know what, it's just better to clean it, right? And then, okay, so we, oh boy, how do I do that? So we load the file, and then we need to say, okay, game data, and this is gonna be a dict, right? And then game is gonna be data from 0, and then it's just gonna pick the, I think it was the game what we have there, right? Let me just double check that. It is a game, yes indeed. Okay, so we put the game here, and then we put review sentences. Or I guess let's call them reviews as well. It's gonna be reviews, and I'm probably doing this wrong. I think that's how you define dictionaries in Python. We're gonna see. Ah, boy, okay. Which means that here into game data, reviews. Oh, Jesus, how do you append again in Python? Append to list. Yes, that's what I want. I think it's something like dot append. Yes, yeah, it is dot append. Reviews append tokens. Okay, so we're gonna push this. All of the list of the tokens is gonna go into reviews. Now we're gonna print game data. Theoretically, we should see a game. And then we're gonna break here so that we don't see, okay, I don't need this semicolon. That's my habit from JavaScript. All right, so theoretically, no, okay, dict as no, oh, right, it's a dict, so we should be reading like that, of course. Dict has no attribute reviews. Ah, god damn it. Okay, are you happy now? Am I, yes, I have fixed all the issues, cool. So that works. We actually have, where's the star? Oh, guy. Okay, there is a lot of reviews. If, break. Why is it so many? Is it really that big? So what is this about? No, PC Gamer. Okay, no, this is PC Gamer. This is Forza Horizon, I guess, right? It's a weird sorting, but okay. Okay, anyway, you know what? I think it looks fine. So what we need to do is now we need to go through these sentences. Okay, you know what? I'm going to remove the breaks. And let's see the whole thing. So there's going to be a lot of text, but the last, yeah, so there's definitely some cleaning that needs to be done. So this one is video review here. So we need to clean all of those /n and /t actually, right? Which means that cleaned sentences is going to be new list, and then we're going to go for sentence in tokens. Okay, clean sentences, append clean sentence is going to be sentence, and then we're going to replace, and now I'm going to search how to replace stuff in Python. Very exciting live stream, eh? Never knew you wanted this. Okay, Python replace string regex. We want a regex that will clean stuff for us. Okay, so it's regex and then sub what's for what's where. Okay, yeah, sure. Oh, it's actually the regex package. Okay. Right, and then this goes over here. This is gonna be, so we're just gonna remove them. And it is gonna be /on/r/t. Yeah, I think that's sufficient. So basically we just remove all of those import re. And if we run, whoops, that is unnecessary symbol. List append takes exactly what, whoa, whoops, I forgot to append it. And all right, and we should add this over here. Okay. So theoretically, we should no longer see so many /n/r's, some UTF-8 stuff, but that should not be theoretically a problem. Because I mean, it is, I think we're using the multilingual model, right? So we pick this embase, what is it? 1 billion training pairs, mean pooling, fine-tuned training, large diverse data set of over 1 billion training pairs. Okay, you know what? Let's give it a shot. So we will try and see whether or not it works. Okay, so now we got game data, we got reviews, which contain a list of lists of sentences, right? So each review is now represented as a list of sentences. So now we need to generate embeddings for them, right? So actually what we want is, instead of having those, I'm going to create a new list. I'm going to call it embeddings. And we're going to create another list, right? And what we're going to do is we're going to say game data embeddings appends. And then, yeah, we're going to generate those from clean sentences, right? So when we want tensors, so I think it returns PyTorch tensors by default, which is quite handy for us because PyTorch has mean function, for example. So we can just, take an average there and see if that works for us. Okay, so in theory, that should give us embeddings in addition to sentences. Okay, embedding. Oh, did I mistype this? Embeddings. Oh, right, I did mistype this. Okay, so now we should get embeddings for each of the document embeddings, right? Yes, we do. Okay, and it is indeed the PyTorch tensors, which is good. That's probably, yeah. Okay. You know what? I'm just gonna break it because it's gonna take some time to generate those, and like I don't know, is stream still good? Because while it is not exactly super heavy task, it still requires some GPU because it does use GPU tensors, right? But that said, we should, okay, so we no longer need that. We no longer need that. We will need this cosine similarity calculation. Okay, question. Okay, so what do we... Oh boy. Okay, let me think for a second. So we now have reviews and we have tensor, or I guess the embeddings for each review, right? As the list of embeddings. All right, I guess we want to save them somehow, pre-compute and save into files so that we can later load them. Okay, model encode. Can I encode them? So this returns PyTorch tensors, which are nice to work with in memory, but we actually want something we can save and load, right? Which means we have to look into the models and see In class, is there an encode? Where's my encode function? Sim encoded. Come on, encode. I guess it's not part of the model. Is it part of the sentence transformer? Whoops. Encode. Yes, there we go. Okay, so we can say convert to numpy. Okay, so this will give us numpy vectors. And then if you say tensor, it will get one large tensor as a result. So override any settings from convert to numpy. Okay, I wonder what is more efficient. Normalize embeddings. Return vector will have length 1. Okay, we don't really need normalization. Device is fine. Show progress bar. I mean, that's also fine. Right, so I'm thinking, I'm now wondering whether we should, you know what? I guess let's try averaging right away, right? Because why the hell not? So I don't want to. I mean, I guess storing it in memory is not that much of a problem. Computing them is more of an issue because it has to run over time. But okay, so we go for reviews, right? So this is for one game. Now we have a game data that has all of the embeddings, which means that we now have, okay, so how do we PyTorch tensor mean? Tensor mean, yes, right. I remember correctly. There is a torch mean. Okay, so it's not a tensor mean, it's torch mean. And then you give it a list. Okay, so we theoretically should be able to just say game data mean equals torch mean game data embeddings, right? So we should be able to just do that. And we need to import torch. Okay, so that should give us mean value for every game unless I screwed something up. And then once this is done, I probably should stop printing it. Okay, I also wonder how long will it take to actually compute those. Oh boy. No, what? Argument 1 must be a tensor, not a list. Okay, so it expects... Wait. Input is an input tensor. Okay, how do I do this? Tensor mean list of... Yes, list of tensors is what I want, right? So I want, yes, get mean... Okay, I already did that at some point, but obviously don't remember how to do that. Torch stack is what we want. Okay, cool. Torch mean, torch stack. So we stack the tensors and then take a mean out of it. I should probably... Well, you know what? Let's print it. So I'm curious how long it will take to generate all of that. And also, let me fire up the performance monitor so we can see if my GPU is dying or not. Oh, Jesus Christ. Okay, yeah. I want... Here's the question. Is GPU loaded because of my... No, okay, yeah. So it does seem to be quite GPU intensive. I hope my stream doesn't die while I'm doing that. So, what is stack expects each tensor to be equal, but got at entry 0 and at entry 1. Aha, so they are... How the hell are they different sizes? That should not be the case. Or I guess they could be different sizes. Okay, so I guess we might need normalization, right? Normalize embeddings. Yeah, okay. In that case, the faster dot product instead of cosine similarity can be used. Aha, okay. So we can normalize, which means then we can get the mean, or we can not normalize and then we can use cosine similarity. Okay, right. Okay, you know what? Let's first... All right, so we got clean sentences. Let's do that. So we got all of this, right? Created game data. Okay, games. I'm gonna create array, and then yeah, this has to go all the way over here. So we're just gonna pre-process all the games, right? And just say, okay, games append game data. We don't even need embeddings here, so it's just gonna be reviews and game. I wonder if we just... No, I mean, there's no point in writing this, right? It doesn't really do much aside from cleaning stuff. So for game in games, and now we're gonna go here, I guess, game data in games, right? This should be replaced to game data reviews Right, okay, so this is going to be for review in-game data reviews, right? So, and then this is going to be for each review, we are going to generate the new embeddings. Okay. So what, okay, let's try it this way. So let's say, yeah, mean, which means that here we also need to say, what was it? Normalize, right? Normalize embeddings, true. So this should be normalized because otherwise we cannot create a mean out of it, right? Let's see if that works. I'm also, again, hoping my computer doesn't die terribly. Please let me know if the stream is lagging or anything like that. Right. We should probably do that as well. So initialize that. I mean, theoretically, my GPU should be sufficient for running the stream and generating embeddings. It's, again, not exactly a super complex task, but just in case the stream decides to die. No, even the even the normalized tensors are different somehow? Or is it the torch stack doesn't work correctly? Ah, okay. Well, I mean, let's try the stupider approach first, I guess. So let's do this. All sentences, right? So we just say, okay, we now have a list of all sentences. And we are gonna generate embeddings for all of them. And then we're just gonna go through reviews. Or I mean, I guess we can just wait. What I want Python combine, I guess, concatenate list of lists and then flatten it is what I want, right? I mean, I obviously know that you can just do plus, right, or append. Yeah, is there a way to just, or y in x, and nah, that's not what I want. Extends, yeah, I guess we can just do append, right? Appends just appends it to the end. This is plus, where's my append? There is append. And it's, yeah, okay, so we can just do append basically. Okay, cool, that works. All sentences, append review, right? So this will append the sentences from review. And now my GPU is gonna die a terrible death because there's like 100 of reviews in some of those. Okay, we no longer need normalization. And if I'm not mistaken, yeah, so we got the reviews, right? We append clean sentences. So if we go into reviews, this is gonna be array of or list of sentences. We append it to other list. That's gonna flatten it. Okay, cool. So I think that should work. I mean, if it doesn't, it will throw an error saying that, hey, you should give a list, not list of lists, right? Okay, right, I forgot that we need, okay, now not append, that should be that. So embeddings in this case become document embeddings for all of the reviews, right? There we go, that actually works. So we got I think this actually was faster than generating embeddings for each and every of the reviews, which is surprising to be honest. Okay, so we can do that. So this means that this generates embeddings for all of the reviews for each of the game, right? So what we need to do now, okay, I can close all of that. What we need to do now is we need to, okay, we no longer need that. We need that similarity thing, right? So we need util, yes, cosine similarity, and we basically need that. Okay. So yeah. So compute cosine similarity output. Right. So this is, it provides scores for each sentence. Okay. Cosine scores. Well, okay. In our case, what we need to do is we need to say for game data in games again. Right, we're gonna go through all of them, and then we're gonna compare each game with each game. And what will be the best way to do that? Oh boy, okay. I think it needs what is the Python for enumerate? We need an index, right? Because we want to compare the current game with all the. Do I actually need an index? Wait. Just take the current game and compare with all the others. And then I take the second game and I need to compare it with all the next ones because we already compared it to the first one. Yeah, okay. So you basically just compare with all the next ones, right? For yes, count element enumerate is what we want. Count game data in enumerate games. Okay. I guess index is the better for it. All right. So current game embeddings is what we want, right? There's going to be game data embeddings. Okay. And then we need to go for, oh boy, how do I do this? Python for, we need a for loop that skips the first, or the skips the current index, right? And then goes, arranges, no, there's no wants, we want, or the, what would be the Python way of doing that? Because I feel like I'm overthinking that. That's probably a super simple way of doing it, right? So we need to start this enumerate, but start it from second index essentially, right? Or I guess drop the, I mean, we can just probably do game data. Why is it game date? For game data in games, if, oh, game data other, let's call it this way, if game data other game equals game data game, we just skip, right? That should be sufficient, right? So basically if it's the same game that we're currently using, nah, but that would still work on the first, oh god, I hate this. Okay, Python for index. Where is the Python for loop with index? Yes, that is what we want. Position name, that is not what I want. I want to start from a specific index and go, I guess it's a range, right? So it should be for Python for range, right? Range? Okay, yes, range. Okay, yes, sure. For index in, or I guess next index, let's call it this way, in range from index +1 to length of games is what we want, right? So I'm gonna shift it to the next game. And then that means that game data next is gonna be games from next index. And then cosine scores is gonna be, this is gonna be current embeddings, and then it's gonna be next embeddings. It's gonna be that. Okay, I really hope I didn't screw anything up. Embeddings. Okay. And okay, for now I'm not gonna, let me just print the whole thing as is. I'm gonna say print game data game. Or I guess we can do print. Yeah, let's do it. Okay, comparing this game with other game is what I want. Format game, and then game data next game, right? And then we just print cosine scores. I think that should do it. Oh Jesus, okay, let's give it a shot. I probably screwed somewhere up, but we're gonna see if that works. Okay, please. Yes, I did. List is out of range. This is from line 160. Wait, what? 161? No, that can 47. Okay, 47 embeddings. Hey, no, that also can't be right. Oh, right. We don't need to. If index is less than length of games Index plus 1. Right, so if we are at the very end, we basically just don't do that, right? I think that's the problem. No, that is not the problem. Embeddings model in code. Well, it is. It says that the... What the hell? Hey, Kamisuzi, you can use F quotes instead of format within. Okay, I mean, I'm not like... I'm not particularly great with Python, let's just put it this way. I mostly build data sciencey things with it that are... I mean, they work, but you know, I'm not overly familiar with that stuff. So let me see. Python F. What is that? What is that? How does that work? Python 3 F strings. Aha. Percent form. Oh yeah, I remember the percent formatting. I've used it a few times. That was in the documentation, but I have not seen F thing. Here. Okay, that's not it. F strings. F. Oh, okay. Oh, damn. That okay. So that's like template literals. Hey, that is definitely my jam. That is great. Okay, and then I can just do. That is, yeah, that's great. Thank you. I absolutely love this way of doing things. That is a lot easier to read. Okay, cool. Now the problem. Why the hell does it embeddings all sentences? So what? Game data embeddings. Yeah. So why is it erroring out now? It says. Annoying to look back and forth. Oh yeah, absolutely. I mean, it is a lot easier to read everything when it's from left to right. I totally agree on that. So it is embeddings, model and code all sentences. It is for some reason complains about this, and it says that index is out of range. Wait, what? Print all send. Okay, let's print them. Is there? No, that looks okay. So this works fine, right? This works fine as well. And then here it errors out. Right. So why is it out of range when it is? That seems like a fine. Okay. Well, there's still some cleaning up that needs to be done, but that should not be a problem. That looks like a proper sentence to me. Interesting. What is going on? Can it be game data game processing game? Okay, let's just log it and see what exactly stumbles it. Maybe we can find something in the data files. Okay, Forza Horizon works fine. Microsoft. Okay, it dies on Undertale. Okay. Why does it die on Undertale? So there's our dataset English. There's the Undertale. And there's our, yeah, it doesn't really have that many reviews. So why is it all of a sudden dying on it? Model and code all sentences. Okay, let's try print f total length of all sentences. Okay. I automate SAP screens and some web stuff. Okay, I never honestly worked with SAP, so. Okay, 58 sentences. It seems like that should be just fine because that's less than previous. Why is it erroring out? Append tokenized text tuple. Okay, so there's definitely some issue with. Okay, it tokenizes the text and then errors out because tuple is malformed. So I'm guessing we need to clean this stuff more, right? Okay. Let's see. I guess let's do /s plus. And then, yeah, I think that's what we want to do, right? So there's definitely some overly inserted spacebars there. Yep, still erroring out. Okay, let's print all sentences. So let's see, is that actually properly filtered out? So I guess that definitely needs some cleaning because things are. I mean, I guess we could ignore that, but we have the data set that is small enough already. Why would we ignore that? Is it because of the UTF symbols in there? Bunch of tables and everything is connected a little bit like a woman's mind. Okay then. I wonder. So I just saw a UTF-8 sequence in here somewhere. Is it because of that? Yeah, there you go. There is now x. What the hell is even that? XA0/XA0. What is this? What is that? Is it like a zero length character or something? String replace. Yeah, I mean, you can just do that, right? Yep. Okay, so seems like we need to clean that as well. So yeah, it's probably seems like it has something to do with the yes, UTF with spacebar, I guess. Is it spacebar? Where is it? Now be the yeah, okay, it definitely is a spacebar, but why the hell is it XA0? Okay. So try it again. Right, so some what? Oh, god damn it, I forgot the string. There we go. No, I'm an idiot. That should be like that. Okay. Are we good now? Nope. Still erroring out. List index out of range. Okay, so let's see. Is there... First of all, did it clean it actually? Well, I don't really see it anymore. Why is it array of arrays? That... Oh, no, okay. No, wait. That's all sentences. Okay, so we need to... Python list flatten is what we want. I guess it doesn't flatten it for some reason. Although, yeah, like I thought combining array of arrays should flatten it, right? Well, okay, yes, we can just add it. Replace. You can also join replaces like that. Okay, I mean, that's fine. So we're using the regular expressions, right? List chain list of lists. Okay, we can import iter. Okay, so we can use iter tools to chain things. We can clean up the code a bit later. Don't worry about that right now too much. I'm just basically want to make it work. Okay, so this stuff, right? And then all sentences. Let's call it flat sentences, right? Okay, are we good now? I'm also have a feeling that we're gonna get more sentences because it probably didn't flatten them properly before either. Okay, this still works. How's our Undertale stuff? Hey, there, okay, so it wasn't basically flattening the array of arrays properly. Interesting. I wonder why. Okay. I probably should remove those excessive prints from there because that is a bit too much information for my taste. But yeah, I mean, it doesn't take too much time to process all of this. Like there's 20 games, it takes, I don't know, 10 seconds per game or something. So it's a few minutes, which, yeah, not too bad. All right. So definitely need to remove the law. Yeah, okay, so we kill that. We don't want to see all the sentences now that it works. But okay, well, let's wait. So theoretically, we should start seeing cosine similarities for all the reviews once it goes through that, right? So there is, that is, I don't know, what is it, 7th, 8th, 14th game or something? Like it should be close to the end right now, right? There's definitely a fair share of junk in there, but whoa, okay. Comparing DaVinci Original Sin with Inside. All right, so you get actually tensors back as well. So we need to, where's my Where's my similarity, semantic text similarity? There we go. Yeah, okay, so we want that, and I guess, okay, for I in range sentences 1. What is the sentences 1 is this one, okay. Right, so this thing gives us a cosine similarity for each sentence. Is there a way? Can I just get like a general score or something? Cosine, okay, similarity in each sentence. Find the pairs with the highest cosine similarity. I guess we have to do it ourselves, basically, right? So we have to. I wonder if we can just sum them up. I mean, technically that would give the overall similarity, right? So if currently it returns a tensor that contains similarities for each pair of sentences, then yeah, cosine score from I is okay. And range So we want range length of cosine scores essentially, right? Or I mean, we do want range here as well. We're gonna print f I and then score cosine I. We don't need that. I think that should do. Yeah, okay. So we definitely need a way to save those tensors, pre-computed. Okay, there we go. Now it shows the correct length of sentences. So 6,000 sentences for Forza Horizon sounds about right. Because like 58 didn't make sense. That was probably the number of reviews. Okay, now it explains why it takes like quite a few seconds to generate the embedding for that, because this document is pretty damn big. Okay, you know what? Let's limit this. So we got this. Yeah, so this is the expensive bit. Let's say we got max embeddings 5. Let's gonna say max embeddings minus equal 1. If max embeddings is 0, then we're just gonna break. So we're gonna calculate 5 embeddings and then run the rest of the code to test it, basically. And if it works, we can, remove it and tweak it essentially. So, very curious to see how good or how bad this will perform. We still need to figure out how to do the. Oh yeah, I mean, I'm guessing the mean tensor didn't work because we didn't. Can it be that the other? Yeah. Okay. So yeah, that looks like we should be able to sum it, right? So. Okay, so that means that we got total score. We got total score that is gonna be plus equals this, right? And then once this is done, we're gonna say total score. And we should get that for 5 games essentially, right? So we should have, well, not 5, there should be more. So it's gonna be 5 for first one, or 4 for first one, 3 for next one, 2 for next one, and then only 1 for the last one, right? If I didn't screw anything in the algorithms, I might have. So we're gonna find out in a second. I mean, theoretically, so if we're looking at the games that are present here, total score is not defined. Oh god, okay. Absolutely screwed this up. So if we look at the first 5 games it picks, there is Forza, there is Microsoft Flight Sim, Undertale, Phantom Pain, Freshly Frosted. Yeah, so Forza and Microsoft Flight Sim should have some similarity. Undertale, I don't think this is gonna be similar with anything. Same goes for Freshly Frosted, at least from this small list. Phantom Pain, what? Index out of bounds for dimension 0 with the size. Okay, what? Where? But you just printed everything correctly. What is going on now? Out of bounds of dimension 0, 21. Okay. That doesn't make any sense. It's just printed everything correctly last time, right? Or did it error out as well? And I just did. Oh, it did error out as well. Okay. Length of sentences. So we want length of, not the cosines. Yeah, but that doesn't, I guess the second index is what? And one is, does that mean that you always have to have two lists of sentences that are similar in the length? Is that what it's saying? We pass converted tensor, returns three metrics, respective cosine similarity. Oh, so you got the x, is it y dimensions is gonna be the number of sentences from the first set, and then y dimensions is gonna be number of sentences from the second set, is what it's saying, right? Which means that we need to, yeah, okay, so this has to be game data. Yeah, okay, so we need to store those flat sentences. Game data. Oh, I mean, I guess we don't need to store them. Sentence count is what we need to store, right? So we can just do that. Okay. Which means that we can use this here, right? And then we can go for y in range game data next sentence count. And then this is gonna be, let's go for x, y so that it's more understandable, right? So we go for x, or I mean, that should be y, but whatever. So we go for one dimension essentially, right? And then we go for other dimension, and then we just add each score for each sentence. I think that should work. So jij pair index sorted pairs. So there we go. There they do this thing a bit. Find the pairs with the highest cosine similarity. So they go, okay, length -1, and then they go i+1 from length. Right, so they go for this pairs. Yeah, okay, so my approach I think should work. We're gonna find out in a second. Okay. That also would give us the total similarity score for all the sentences summed up, be it positive or negative, right? I wonder if we need to divide it by the number of sentences we had there so that it's sort of normalized. Maybe we don't. Yeah, we probably need to normalize, right? Because the longer reviews then are going to be biased or sort of always look like they are more similar. Not even correct way of saying it. Oh boy, okay, that's gonna take a while. That's probably quite a lot of dimension. I mean, yeah, it's basically 5,000 by 5,000, right? So that's quite a result there. Okay, perhaps there's an easier way of just summing it up. You know what? Let's do max embeddings 2. And then hold a second over here. So just gonna comment all of that. Did we get a tensor back? Was it a tensor? Cosine scores. Yeah, okay, that's gonna take ages, which makes perfect sense because there's, yeah, like 5,000 by 5,000 is, oh boy, a bit too much. So do we get a tensor back or what is it? Yes, we get a tensor back. And each tensor... catching up. You are limited to 100,000 calls to Steam API per day. I haven't done any today. And you've seen what happened when I started the scripts. It's just, I think the API is broken. And I mean, if you're rate limited, it should give you the error, right? That you are rate limited. So that's definitely not the problem. Okay, so yeah, this is cosine scores, pairs append, index. Yeah, I mean, is there a way? Okay. I wonder if there's a way to do this efficiently because this, yeah, this is gonna take some time. Tensor. Whoops. PyTorch. PyTorch, we want torch tensor. Yes, we want checkpoint. No, that's not what we want. Where's the, yeah, that's the tensor class, right? So we want class reference. What kind of functions do we have to work with? New tensor, device, grads, and absolute value. No, I mean, we don't need absolute. We want, I mean, we actually want average, right? That, is there a method for that that is efficient so that I don't have to do this myself? Like, that would be good. All, any, mean? I mean, mean should do that, right? So returns mean value of all elements. Yeah, that's exactly what we want. Okay, true. So yeah, yeah, right. So that's gonna be mean score, basically, right? Torch mean cosine scores is what we want. But hold up, that means, is that an array of tensors or just one tensor? That looks like one tensor, right? Okay, so if we just do mean, I think that should do it. Okay, let's see. Theoretically, okay, if, I mean, I have more faith in PyTorch developers than in myself, basically, so I think that should be a lot more faster than just naively adding. Oh yeah, right, we don't have any eyes over here, so this should be just that. But it didn't error out on doing the mean out of it, right? So that means that that part works, which means that we should see the mean score. Come now. Show us, no, what? Embeddings, eh? Sorry, what now? Next embeddings, key error. Score. Okay, so we do get the score, but now it errors out and says next in there. Why are you erroring out? Oh, because we didn't calculate them. Right, okay, of course. That makes perfect sense. It errors out because there are no embeddings calculated for any other game, basically, so it just dies. Okay, let's try in 5 games. I probably should back Control C. We need to kill that. So we don't want to see the full tensor because it doesn't matter for us, right? I am very curious. So we got 20 games, which means there will be quite a few similarity pairs. Let's see. So theoretically, the first 5 we pick, they should all have very low similarity, right? Yeah, I mean, yeah, Forza and Microsoft Flight Sim has the most similarity, but it's like, yeah. Okay, let's try running all, I guess, and see if that actually produces any decent result. I mean, what is our data set? Let me have a look at the games list. So we got Red Dead Redemption, Elden Ring, Hades, Divinity Original Sin, Undertale, Dead Cells, MGS5, Witcher. Yeah, okay, there's quite a few that should be similar, at least in my head. So we're gonna see, whoa, what is going on. Max embeddings is not defined. Oh god, I forgot to remove the, yes, right, we don't need that anymore. We want to run the full thing. Okay. There you go, moment of truth. So there is, there's 20 games, right? And there's definitely more than a few that should be similar. We should, I mean, okay, let's just run the whole thing through, see the similarity score, and then basically make it a bit nicer, I guess, and then it will be a good place to stop the stream. So this is the document embeddings approach, essentially, right? We just thrown everything together and said, hey, okay, generate embeddings for this really large document of 6,000 sentences, which surprisingly worked quite well. It's not even that long. Oh, Jesus Christ, Red Dead Redemption. 11,000 sentences. That, I hope my, well, it's a good thing it's not warm here, so my GPU won't overheat and melt. Okay, Elden Ring is not much better. But yeah, I would be also interested in seeing sort of trying to do the mean across, so generate embeddings for each review and then do mean of those, right? And see if that provides better matching. Cats just decided to start fighting. It's like a moment ago they sleep together and now they just fight over there. Okay, right, so we are halfway through the list or something. That should be, I mean, majority of games are actually small. I think like Elden Ring, Red Dead Redemption 2 are the largest ones that have the insane amount of reviews. Everything else is a lot more conservative. Okay, let's see. And right, so we got a whole ton of comparisons here. So that's too much. And there we go. Okay, let's see. So Forza and everything else. Let's just copy this. That is, yeah, probably not the best way to represent it. So we should work on the presentation. But okay, so if we sort by similarity, then yes. So Forza is the most similar to Microsoft Flight Sim, which makes perfect sense, right? I don't think we have any other racing games here. So that seems to be performing as expected. Then we got Microsoft Flight Sim. And we compare it to everything else. Well, again, that should not really be, I mean, I don't even know what it would be similar to, because everything else is like RPGs and story-driven games. And I guess there's some similarity to, like, yeah, so the Metal Gear Solid has the most because it probably mentions planes and cars or something. So, yeah, okay. Then we got Undertale. Undertale, yes. Okay, so Undertale, Ori and the Will of Wisps, Witcher, yeah, I mean, that's fair. So those are relatively similar. Elden Ring, kinda. Undertale, Nier Automata, okay, that's Celeste. Okay, those definitely are similar in sort of their indie games, right? Sorry if YouTube is on delay and my last message has a link. So the problem is YouTube eats the links. So if you want to share something, please throw it into the Discord and tag me there, because, yeah, or Twitch. I think Twitch is less restrictive with that. YouTube absolutely eats links, and like, you cannot share anything in the chat. And unfortunately, I have no control over that. But let me have a look. If you want to do something a little more lightweight, you can do fuzzy joins. Google fuzzy joins tutorial. Okay, Google fuzzy joins tutorial. Let me have a look at that. What is fuzzy joins? That is predictive hacks. Fuzzy data frame. Okay, so this uses data frames. Takes distance. First thing. How does this work? Actually, refers to Levenstein. So, but that's like Levenstein-based stuff, right? But that's the problem. The problem with just comparing text is that it's not going to work for games for sure, right? Because a lot of writers use synonyms. A lot of reviews try to be, use literature language, so they are all like very or trying not to repeat themselves and well written, and all this thing like metaphors, synonyms, all that business, right? So comparing text will absolutely not work. I can immediately tell you that similarity like this will not get you far enough. Semantic similarity is great because it compares things not just word to word, but actually meaning to meaning, right? That's kind of the whole point of embeddings. And as we can see here, it does seem to be producing decent enough results. So we have, okay, let's have a look. We had a look at the Undertale. Metal Gear Solid 5. Let's have a look at that. So what is the Metal Gear Solid 5? And it is now for some reason marked down, which is fine, I guess. So what is the most similar thing? So it says Resident Evil 2 and Nier Automata, which is, I guess, fair. Yeah, so it seems like it does produce the decent results. So then we got the freshly frosted stuff. Honestly don't know what it would be similar to. I think it's like a casual game, so yeah, Celeste probably. Ori and the Will of Wisp. Nier Automata. Yeah, there's a lot of platforming, so I guess it checks out. Witcher 3, that should be similar to something like Divinity. Well, not really. Okay, interesting. Nier, yeah, okay, Nier, fair. Then we got Red Dead Redemption. Okay. It seems like it's decent enough, but I don't know if it's... Like, on such a small data set, it's very hard to say if it's any good, basically, as a practical application. But it seems to be working well enough, right? So I probably would need to adjust those, because some of those are way too similar, like way more similar than I would expect it. Let's just put it this way. So Rayman is, for example, quite similar to Nier Automata, right? It's like 0.17 or 17%, I guess, right? I guess that's probably not is it percentage of similarity? What does it return? Format sentences. This is everybody respective cosine similarity scores of all possible pairs. Yeah, so it is a cosine similarity scores. Okay, yeah. It sort of works, but I don't know how good that is. So we would we'll be curious to try it on a bigger data set, but that probably requires some power. And I would also want to see how the mean... I mean, we can probably do that, right? So theoretically, we got the clean sentences, which means that we can do flat sentences for clean sentences over here, right? And then we should be able to generate embeddings. How about looking into BERT transfer? I mean, we are using BERT, or I think it's not the BERT directly, but it is BERT-like embeddings, let's put it this way. I don't know if we need transfer learning here. I think just embeddings should be more than enough. It's just a matter of finding the right way to compare them. Okay, so let's see. We got reviews. Right, so we need... Let's call them review embeddings. So let's generate embeddings for each review. Whoops, no, that's, you're gonna go into review embeddings, append embeddings, okay. So we got flat sentences, and then we do embeddings, and then we convert them, and then we append them. Okay, cool. So that theoretically should generate embeddings for all of the reviews, right? Which means that then we should be able to... Okay, those are overall embeddings. This means that here we should be able to say... Wait, but we cannot just do torch mean, because this gives means for the given tensor, and that's not what we want. We actually want computed for non-element. Yeah, okay. Okay. So this is something I will have to look into, as in how do we take a set of tensors and create a mean out of that? And there's gotta be some efficient way of doing that as well. I mean, obviously we can do it manually, but that sounds just as bad as trying to do the mean average of the tensor like we did here, right? So that's probably not gonna fly. Okay, right, I think yes, probably would be a good... Okay, let me try to run that and see if that works. That is probably also a good point to stop this. There's been quite a long stream. We'll have to dig into that, but I'm curious. I wonder if I'm like, if this mean is representing what I think it does. Maybe I'm just mistaken here. I will have to dig into that a bit and see. So yeah, so next time we're gonna try to do the whole thing with the average of reviews and try to compare those tensors using cosine similarity, right? Because that should be a lot easier, because we no longer need to have those incredibly large embeddings from thousands of sentences. Instead, it's just gonna be one small-ish tensor, and it's should be in theory a lot more efficient, right? We're gonna see how that goes. Let me just commit what I did. If you guys have any questions or suggestions, feel free to throw them into the chat right now. Git commit at basic embeddings based similarity review, or I guess game similarity comparison. Yeah, I would need to look into that a bit more because I feel like I'm doing something slightly wrong because the results are a bit too close to each other. So I'm not sure. Not sure if it's me messing something up in the code or if it's me misunderstanding what torch mean does here. Maybe that is the wrong method to use, but we're gonna see. So we're gonna basically continue the next Wednesday. I'm gonna report back on my findings and whether I screwed up or not. And we're gonna try the other approach. Again, I'm gonna try to find out before the stream on how exactly it is done in the most efficient manner, so we don't have to write our own method to create an average tensor out of what we have. But yeah, that's pretty much it from my side. So if there are no more questions or suggestions, yeah, thank you very much for watching. There's always Discord where you can join and chat about anything. The code is on GitHub as usual. Yeah, that was entertaining, to be honest. I did not expect the results I've seen today. I still have a feeling that something is a bit off. Although the generally code looks like it should work. We're gonna see. We're gonna see where this takes us. So yeah, thank you very much for watching, guys. I hope you enjoyed the stream. Again, join Discord if you have any questions you want to ask outside of the YouTube, or throw them into the comments if you're watching the VOD. We'll be more than happy to chat, and I'll see you next Wednesday.